and welcome to another WJEC A level physics question. This time it's a Unit 1 question from May in 2013, and it was question 6 on that paper, and it's basically a forces question. So first part of the question, we've got a man pulling a tree trunk with a force of 600 newtons at an angle of 40 degrees to the horizontal, as we can see on the diagram. We've got to calculate the forward component, the horizontal component of the 600 Newton force pulling the tree trunk forwards. So if I call this, for argument's sake, FH, then remember to resolve a force in a particular direction, we just multiply the force by cos of the angle that we turn through to get to the direction that we need. So here FH is going to be 600 cos of 40. Just make sure you're not in radians mode on your calculator. When we work that out, it comes out as near enough 460 newtons, and I'm going to store that in memory A of my calculator because I'm going to use it again a little bit later on. The next part, to find the vertical component, I'll call it FV. Well, if the horizontal component is cos of 40, the vertical component is sine of 40. Alternatively here we could use 600 cos 50. Because we turn through 50 degrees to take the 600 Newton vector vertically. That answer, once we type it into the calculator, is 386 newtons. And again, I'm going to store that in a memory. I'm going to stick it in memory B, so that I've got both answers available for later. Now the next part of the question says, using your answer to A2 and taking the mass of the tree trunk to be 90 kilograms, determine the vertical force between the tree trunk and the ground. So a little diagram here, a free body diagram might help. So there's a little box just to represent the tree. Well, downwards we've got the tree's weight, or the trunk's weight, which is 90 times 9.81 newtons. We've got an upward pulling force, which we've worked out in part A2, which was 386 newtons. Now this tree trunk isn't accelerating in a vertical direction, so there must be another upward force, because the bottom force is roughly 900 newtons. So I'm going to label this upward force as, I'll just call it N for a normal reaction force. It's basically the push of the ground on the tree trunk, and that's almost what the question asks us to determine. It wants us to determine the vertical force between the tree trunk and the ground. So what they're sort of asking for is the force of the tree trunk on the ground, and by Newton's third law that's exactly the same as the force of the ground on the tree trunk. So really we're just trying to find force N in this diagram. So what we can simply say here is that the sum of the forces in the upward direction must equal the sum of the forces in the downward direction. So upwards we've got 386 plus N, downwards we've got the 90 times 9.81. So N then is going to be 90 times 9.81. Take away the 386 that we stored in memory B. So let me just plug that into a calculator. So that gives us 497 newtons. The next part of the question tells us that the horizontal frictional force acting on the tree trunk is 0.8 times that force that we've just worked out. We've got to find the acceleration of the tree trunk. So let's find that frictional force first. So if I just call it friction for a moment, that's going to be 0.8 times the 497 newtons that we just worked out. No need to store that in a memory because we've got the last answer button to use there. So that gives us about 398 newtons. Now if we're going to find the acceleration of the tree trunk, we're going to apply Newton's second law in the form of sigma f equals ma, rearranged to a equals sigma f over m. Now you've got to remember that sigma f is the resultant force. So horizontally, if we go back to the original diagram, we've got 460 newtons being pulled to the left, and this 398 newtons of friction to the right. And when forces are in opposite directions, we simply subtract. So now we're ready to calculate that acceleration. So remember that 460 was alpha A, was stored in memory A with the Casio calculators. And if we plug that in, we end up with 0.687, so let's call that 0.69 meters per second squared. The final part of the question asks us to find the weight of tells us that the weight of the tree trunk is a measure of the Earth's gravitational pull on the tree trunk, and we've got to identify the Newton's third law, equal and opposite force to the weight of the tree trunk. So all we've got to do here is remember, when we write a Newton's third law pair, we just swap the objects. So the third law pair is, instead of the Earth's gravitational pull on the tree trunk, it's going to be the tree trunk's gravitational pull on the Earth. So very easy, just simply swap the two objects around. Thank you for listening. Please remember to like and subscribe, and feel free to add any comments below. Goodbye.